Hello learner, welcome again to Manifested e-learning platform. We are yet again going to continue with our topic on three-dimensional geometry, and today our lesson will be angle between two planes. So the lesson, and as usual, our lesson should have an objective. So at the end of this lesson, the learner should be able to identify an angle between any two given planes and also calculate it. So we have our objective. So the learner should be able to identify the angle between two planes and also calculate it. Take, for example, a classroom. It has a floor and the four walls. The four walls act like four planes plus an additional plane, which is the floor. Or if it is you look at it carefully, the planes meet at 90 degrees, but not all planes will be meeting at 90 degrees. You might find some meeting at an obtuse angle or acute angle. So if we take let us look on the board. We have plane A, B, C, D and C, D, E, F. Plane A, B, C, D and C, D, E, F. Initially, we found that if we have a line and you sweep it through a fixed distance, you get a plane. The same for the other plane. Have a line and sweep it, you get a definite plane. So usually, if you consider that the plane, a plane is just a composition of many lines. And actually the line was moved at 90 degrees. The line, the line taken on the plane should be perpendicular to the edge of that plane. So if you look at that angle theta and angle theta. So if you look at our diagram, the angle between plane CDAB and CDEF is theta. The angle between those two planes is theta. There is something you identify. The angle is actually got by taking a line perpendicular to the edge of the other plane. A line perpendicular to the edge of that plane. In the other plane, you take a line perpendicular to the edges of the plane. That is where you fix the angle. So this angle will also be equal to theta. So there is something you notice. The line that is very important. You should notice that. So we shall go straight to an example, a very good example. We call it example 4. So there is a figure there, represents a cuboid. You can try to shade that in the figure. So you realize in the question, it stimulates you to first of all getting a line. When you get a line on a plane with the other plane, it's just the same as the angle between the line, the plane where the line is and the other plane. So we shall go to our diagram. In the figure, N and M are the midpoints of BF and CG respectively. So you are told, find the angle between, we come to A, solutions. We have A, find the angle between BD and BCGF. BCGF. So they're talking of BD. So this is E. They are talking of BD and BCGF. BCGF. Where is BD? So you have to get, my D is here. BD. So when you are told that, you should trace that line, BD. BD and BCGF. So if you look well, there are two angles there. You can either have this angle or the other angle at the end of the other face. So that angle, this is the first angle. In A, you'll get which angle? You'll get angle DBC, angle DBC, or you can still get another angle at the end there, HFG. We come to B. AC and plane ABFE. AC and plane, you look at this, AC and plane ABEF. ABFE. So you look at AC and this plane, AB and ABEF. So you look at this angle and that plane. So you find it is angle CAB. Or it can be at this edge, this one, or the other angle, GEF. So we move to the third one, C. EM, we look where EM is. EM and plane DHGC. EM. So they are looking at this. So you look at that angle. So what you need to do, the way that angle is moving, you will be forced also to slant this, because it will be at that plane. So you will be looking at that angle. So they are talking of the angle between EM and plane DHGC. So you look at angle EMG. Note that carefully. You join M to where this plane is. So where M is, it will take a straight point in the plane. So it will be angle MEG. It will be angle, it will be angle GEM. Lastly, MD. Lastly, MD and ADHE. MD, MD, MD and ADHE. ADHE. So they are looking ADHE. So they are looking at this angle. MD, you'll be looking at this angle. It will be angle MDH. Angle MDH. It can also be the same angle as NAE. NAE or angle MNE. So having looked at that, we shall look at a numerical example, example 2. So you're told that is the figure for the diagram. So this one is given as 10. So those are the questions. Calculate QR, calculate angle QRC, and calculate the angle between planes ABCD and PQRS, and D, the angle of inclination between PR and the horizontal. So we go straight to the solutions. The solutions, QR, you look for where QR is. QR is the same as BC. So it will be the same as QR is the same as BC. QX is the same as BC. So BC is 30. 30 centimeters. So when you come to work out that, they said you should have known Pythagoras theorem. So you realize QR squared will be equal to QX squared plus RX squared. So QR squared will be equal to QX 30 squared plus 10 squared. So this will come to 900 plus 100. So this will give you 1000. So QR will be equal to the square root of 1000. Square root of 1000, which you will need to work out very fast. Square root of 1000. Square root of 1000. Give 31.62. Square root of 1000, which is 31.62. 31.62. We move to the second question. Angle QRC. You note C is somewhere here. So they are talking about that angle. They are talking about that angle. So B, you'll say, using the figure in A, you'll say tan theta. Theta is equals to angle QRC. So you'll say tan theta will be equal to 30 over 10, which gives you 3. Opposite of adjacent gives you 3. So tan theta will be tan inverse 3. So the value of angle theta will give you go back to your calculator. Go to your calculator. Tan inverse 3, which is 71.56 degrees. We move to C. Calculate the angle or between planes ABCD and PQRS. ABCD and PQRS. So you come and look at that. ABCD. So you note there was a slight, you're talking of ABCD and PQRS. So note that if we have this plane, if we are to prolong this plane, if we are to prolong that plane would look the same as it is still horizontal to plane PQXY. So you realize plane is horizontal to plane PQXY. So when you talk of this angle, since it is horizontal to this, even if you project this PQXY, so they are talking about the angle between ABCD and PQRS. So it will still be the same as this angle. You can tell that angle to be angle alpha. So you'll come and the angle in question will still be this one. You'll have your XR, which is 10, and you'll have your Q here. Because I've said this plane is still horizontal to this. It is still horizontal to that. So if you project, it will still meet this one at the same angle. So come and say this one is 30. That is angle alpha. So you'll say tan alpha is equal to 10 over 3 over 10 over 30, which is 0.3333. So alpha, that angle will be tan inverse 0.333. So you work out quickly with your calculators. You get 18.43 degrees. That's the angle. Angle of inclination between PR. They are talking of these. So this is PR. This will be X, RX. Look, Lana, Rx is 10, but I need to find Px. If I have this as 30, 40 and 30, Px is equal to the square root of 40 squared plus 30 squared, which is the square root of, add the two, 1600 plus 900 So Px is equal to the square root of 2500, which is 50. So I get my Px is what? 50 centimeters. I can call this angle theta. So if they want that angle, I'll take tan theta is equals to opposite of adjacent. So it's 1 over 5, which is 0.2. So theta will be the tan inverse 0.2. So with your calculator, back to the calculator, tan inverse 0.2. It will give you 11.30 degrees. So angle between PR and horizontal is 11.3, approximate to 1 decimal place, 2 decimal place, 11.31 degrees. So for the assignment, for that assignment, we shall have mathematics for Kenya schools by Patel. You'll do exercise 5.1, number 5, and number 6, exercise 5.2, number 2, 3, 4, and 6. So as we end the lesson, learner, look at the relationships we've been having. They say the prerequisite knowledge for this was Pythagoras theorem and some trigonometry. So you should be able to get the angles in the subsequent question. So as I end the lesson, I hope you'll go through the solutions to get a proper test of the angle between lines, planes, and planes, and planes. So thank you for your audience and have a good time. Bye.